is brought to you by Order of Operations. Order of Operations, do it in the right order or you get the wrong answer. Order of Operations. Why do we have the order of operations? Why? What's so important about it? What is it? Well, in order to say that mathematics is the language of the universe, we all have to be speaking the same language, right? So if we're presented with a mathematical problem and there are multiple people trying to figure out this mathematical problem, there has to be some consistent process that each of them is using so that there is a universal truth to it, right? Because if I'm doing the same math problem as a student sitting in India, and we have the same exact problem, but we get two different solutions, one of us, or neither of us, have to be correct, right? We can't say that we're both correct if we got two different things. And that's what the order of operations actually does. It gives us a set of rules that all of us have to follow in this universe in order to be speaking the same language. And so what exactly is the order of operations? Well, the order of operations is the order in which we perform the basic operations in mathematics: addition, subtraction, multiplication, division. And it's the specific order in which we actually have to perform those operations if there is more than one inside a math problem. And so some of us remember that the order of operations follows this little mnemonic device called PEMDAS. And some of you may even remember this as, "Please excuse my dear Aunt Sally." And so I want to just present you with an alternative to this, okay? And the reason I want to present you with an alternative is because of that very first letter, which in this case stands for parentheses. But really, what we're not talking about is doing things that are in parentheses first. What we're talking about is doing things that are in groups first. So I want to change this. Instead of saying PEMDAS, I'd like to call this GEMDAS, right? GEMDAS. Because what I want us to do first are the things that are in groups, not necessarily parentheses, but groups. So let's talk about groups, right? We're going to do things that are in groups first. But groups can be made with different types of mathematical symbology. We maybe use brackets to show groups. That would be like this, right? We could use parentheses. Parentheses would be like this. But then there are some types of math symbols that act as groups, even though we may not think of them as groups. For example, the fraction bar. The fraction bar creates an implicit group, right? So if we have a fraction bar, the top, the numerator, is considered a group, and the denominator is considered a group, even though we may not have any grouping symbols to represent that group. Other ways we might see groups could be in a radical symbol. In a radical symbol, right? Things underneath radical signs could be considered groups. And also, the last one could be something like absolute value symbols. You may or may not have seen absolute value symbols. Those are vertical lines, right? And inside those vertical lines, we have some kind of numerical representation. But the absolute value symbols can be considered grouping symbols as well. I just want to remind you what the absolute value actually means. The absolute value means the distance from 0 on the number line. Distance from 0 on the number line. And we measure distances with positive values. The distance from me to home is the same as the distance from home to me. We don't represent one with a positive and one with a negative. So for example, if I said, well, the absolute value of 2 minus 3, what's inside those absolute value symbols are going to be considered a group. So we're going to do that operation. 2 minus 3 is negative 1. So we had the square root of -1. And then we ask ourselves, all right, well, how far away is -1 from 0 on the number line? Well, -1 is 1 unit away from 0 on the number line. So the absolute value of -1 is 1. These are different ways that we represent groups when it comes to the order of operations. After we perform anything that's inside of groups, we want to undo any of the exponents that are in the problem, or we want to do the exponents in the problem. So let's talk about exponents for a second. What exactly is an exponent? An exponent is a value which tells us how many times we multiply a number or a value by itself. Multiply something by itself. And that something could be a number, it could be a variable, it could be an expression, but an exponent tells us how many times we multiply something by itself. Let's take a look at this example. If I said, how would I read this? It would say 3 to the 5th power. 3 to the 5th power. Let's break this down and talk about the different parts, okay? So the first thing we notice is that we have this big number here. This big number here, this is called the base. Okay, so the big thing that you see in an exponential expression is called the base. And the small thing that's up in the upper right, it's always written in the upper right, this is actually called the exponent. And together, a base and an exponent form something called a power. Right? So we have the base, which is being raised to some exponent, and together the base and the exponent form something called a power. So how do we simplify this exponential expression? Well, what does 3 to the 5th power actually mean? Remember, an exponent tells us how many times the base is being multiplied by itself. So that would be 3 times 3 times 3 times 3 times 3. Notice there's 5 of them being multiplied together. And if we were going to simplify this, we would have to multiply all of those 3's together. 3 times 3 times 3 times 3 times 3. Maybe we can use a little shortcut here. 3 times 3 is 9. 3 times 3 is 9. So we have 9 times 9 times 3. This is 81. 81 times 3 is 243. So 3 times 3 times 3 times 3 times 3 is 243. We could see exponents in lots of different types of expressions. For example, what if we had a fraction that was being raised to some exponent? Well, there are two ways that we can actually look at this. Because when something is squared, it means something times itself. This literally means that we have 2/3 times 2/3, right? In multiplying fractions, I want you to remember, we multiply across the numerator and multiply across the denominator. That would leave us with 4/9. That's one way we can look at it. Another way we can look at it is that 2/3 to the 2nd power is the same thing as the numerator squared over the denominator squared. Right? So we have 2 squared over 3 squared. And 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. And so there's our fraction 4/9. That's another way that we can actually look at it. So I'm asking you here to simplify this exponential expression. And to simplify just means that we're trying to achieve a single numerical value, like 243 or 4/9. Moving on, after we perform the exponents, we're going to do any multiplication and division. So multiplication and division. And if there's more than one multiplication and division in a problem, you're going to work left to right. Left to right. Now, sometimes that means division is going to be before multiplication. If the division is further left, then we're going to do that first. Once all the multiplication and division is done from left to right, then we move on to addition and subtraction. And the same rule applies to addition and subtraction. we're going to work on all the addition and all the subtraction left to right. Let's take a look at an expression that I'm going to ask you to simplify using the order of operations. So if I said this, give me a second to write this down. Okay, and I asked you to simplify this numerical expression using the order of operations. Then we have to follow those order of operations in the right order. So remember what we do first. We do things that are in groups first. And so if we look at what's inside of groups, we have this set of brackets here. And even within groups, you have to perform the order of operations in order. So if we're looking inside of a group and we see more than one operation, we do have to do them in PEMDAS order as well. Now I want to take care of the exponent first, right? 8 times 3 squared is 9. So I took care of that. And I want you to notice how I'm going about doing a problem like this. I'm doing it one step at a time. 8 times 9 is 72. So this becomes 72 divided by 6 minus 5 plus 1/2. I have taken care of all the groups, taken care of the exponents, and now it's multiplication and division time. So here's my multiplication and division, right? There's my multiplication. 72 divided by 6 is 12. So now I have 12 minus 5 plus 1/2. What comes next? Addition and subtraction, left to right. Now notice, I have both subtraction and addition in this problem, but I need to work left to right. So I'm going to do the 12 minus 5 first. 12 minus 5 is 7. So 7 plus 1/2. I'm on my very last step here. 7 plus 1/2 is 7.5. So I've simplified this using the order of operations. Let's look at one more way that we use the order of operations. And this time, we're going to do something called evaluate. When you're asked to evaluate, what you're asked to do is you're asked to substitute values into an expression and then simplify. So this is an example of a case where I would have to evaluate because I would need to substitute values into the problem and then simplify, right? So I have a squared divided by b minus the quantity, c plus d. And then over on the side here, I give you what the actual values of a, b, c, and d are. So the first thing we're going to do is substitute and rewrite what the expression tells us. So we have 8 squared divided by 2 minus, parentheses, or brackets, -1 plus 3. All I did was substitute the numbers that were given to me into the expression. And now I'm going to go ahead and use the order of operations to help me out. So I'm going to do whatever's in groups first. Groups come first. So everything else stays the same except for what's in the group. -1 plus 3 is 2. All right, now we move on to any exponents. Exponents, 8 squared is 64. So we have 64 divided by 2 minus 2. Now I need to do my multiplication and division. 64 divided by 2 is 32. So 32 minus 2, 32 minus 2. 32 minus 2. And that gives me 30. So here, I did something called evaluate and then simplify. So the order of operations is the order in which operations need to be performed when we have a problem with multiple operations in it, okay? The reason we need to do that is so that we are all speaking the same language universally when it comes to mathematics, and that there is one accepted truth and one accepted answer to all of these problems. I'm going to give you some time to practice using the order of operations here. And please send me a message if you don't understand or you're having trouble.